Hi everybody, this video will go over the homework associated with section 4.1, Introduction to Probability. As before, I have my Hawks lesson page here, and I have one note here where I can do a little bit of writing. And as usual, we have our three components: learn, practice, and certify. And I will be going through practice. Just keep in mind, practice does the exact same problems as certify does, but it will give you more constructive feedback. However, to complete your homework, you have to certify with getting no more than 3 questions wrong before the due date. So let's go ahead and get started. Here is our first question. A coin is tossed 7 times. What is the probability of getting all tails? And they want your answer as a simplified expression or as a decimal rounded to 4 decimal places. Now, as we mentioned in the previous video, I think it was the second one, if we toss a coin once, there are 2 possibilities, heads or tails. If we toss a coin twice, there are 4 possibilities, or 2 squared possibilities. Heads, 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 tails, tails, heads, tails, tails. I'm sorry, that should be 2 squared, not 2 to the 4th. If you tossed it 3 times, there would be 2 cubed possibilities. If you tossed it 4 times, there would be 2 to the 4th, and you guessed it, if you tossed it 7 times, your sample space would have 2 to the 7th possibilities, which is 128. Okay, so the probability of getting all tails is going to be the number of outcomes associated with getting all tails divided by the total number of possible outcomes. The total number of possible outcomes is 128. And there is only one way, there's only one outcome that has all tails. That is every single dice or every single coin ends up with a tail. So there is exactly one outcome. As a consequence, that's your answer. 1 over 128. Now to put this into Hawks, what you can do is type in 1 followed by the slash. Now to get to the denominator, you're going to need to use your tab. Type in 128, and there you go. Okay, that brings us to question 2. What do we have for question 2? Okay, here we have it. This looks like one of our examples. Here we have an 8-sided die which may or may not be fair and has 4 colors on it. If you have been tossing a die for an hour, and we're assuming that you've tossed the die for an hour and recorded the color for each toss, what is the probability that you will roll a purple on the next toss of your die? Okay, well this is a relative frequency notion. So the probability of rolling a purple, I guess I should call that PU, not for stinky, but for purple, is going to be the number of trials where a purple actually showed divided by the total number of trials. Okay, so that will be 35 divided by 35 plus 31 plus 22 plus 39. I guess I should have given myself a little more room there. It turns out the denominator sums to 127. So we will have 35 divided by 127. Now the only thing we need to do is first determine if this is a reduced fraction. And it is not. Turns out that both have a common factor of 7. So if you factor that out, we will have 7 over 25. If you wanted to write this as a decimal, this would be 0.28. So let's just go ahead and do that. Okay, so far so good. Okay, here comes question 3. We are going to play miniature golf, my wife's favorite activity. A ball machine that contains 19 green balls, 21 red golf balls, and 18 blue golf balls, and 24 yellow golf balls randomly gives you your ball. What is the probability that you end up with a green golf ball? Once again, the probability of getting green is going to be equal to the number of green golf balls divided by the total number of golf balls. Number of green golf balls happens to be 19. The total number of golf balls is going to be 19 plus 21 plus 18 plus 24, which will give us 82. So we will have 19 divided by 82. Now, the big question here is this a reduced fraction? And the answer is yes, yes it is. How do I know it's a reduced fraction? Well, this happens to be a prime number. The only factors here are 19 and 1, and since 19 is and 82 is not a factor of 19, so this would be sufficient. So you could write this as an answer, or you could write in 0.2317. I'm going to go with 19 over 82. 19/tab 82, and I made a mistake. What was my mistake? Well, notice here, since I made a mistake, it can explain my error, or I can try again. I think I know what my mistake is. I meant to put in 19, I typed in 18. So let's go ahead and just correct that. So changing this to 19. Resubmit my answer, and there we go, now I am correct. And that brings us to 4. We're almost halfway there. We have a standard 6-sided die that is rolled. What is the probability of rolling a 5? And we can express our answer as a simplified fraction or a decimal rounded to 4 decimal places. This should be straightforward for most of you. The probability of rolling a 5 is going to be equal to the number of outcomes associated with a 5 divided by the total number of outcomes. Well, remember, we're rolling a dice. There's only 6 outcomes, one for each side. And there's only one side with 5 dots. So there we go. That's our answer, 1/6. 1/tab 6. And that brings us right along to question 5. Here we have a box that contains 95 red marbles, 58 white marbles, and 3 blue marbles. If a marble is randomly drawn from the box, what is the probability that it is white or blue? Okay, so we want to find the probability of drawing a white or blue marble. All right, well, that's going to be equal to the number of marbles that are either white or blue divided by the total number of marbles. The number of marbles that are white or blue are going to be 58 plus 3. The total number of marbles is going to be 95 plus 58 plus 3. 58 plus 3, that is 61. Total number of marbles is 156. 61 divided by 156 is going to be equal to 0.3910. It turns out that the 5th decimal place is actually going to be a 2, so we would not round up. So it turns out we can either put this in for an answer, because that is indeed simplified, or we can just go ahead and use the decimal, which is 0.3910. And there you go. Okay, 3 problems left. Here we need to write down the sample space and use the letter heads for H for heads and T for tails. Okay, here we have 2 coins are tossed. So this is actually the same as one coin being tossed twice. So if you toss 2 coins, there's what are the possibilities? Well, the first coin can either be heads or tails. The other coin can also either be heads or tails. Okay, and regardless of what the first coin does, the second coin can once again be heads or tails. So this forms a tree for us, and this is our tree. Then all we need to do is start the root and go down each branch to highlight the tree, or to define all of our outcomes. First one is heads, heads. Comma, the next one is heads, tails. The third one is tails, heads. And the fourth one is tails, tails. And that is exactly what you want to put in here. Notice here we want to separate our answers using commas. So it's going to be H, H, comma, HT, comma, TH, comma, TT. No comma. And that's your answer. Okay. Now to problem 7. Write out the sample space for the given experiment. Use the letters to indicate each choice. O for orange, Y for yellow, W for white, E for ebony, C for cherry, and U for unfinished. And while renovating a house, we have a choice of paint colors for our game room. They happen to be either orange, yellow, or white. We also have the following options for the finish for your entertainment center in your game room. Ebony, cherry, or not finished at all. And they want us to write out the sample space. Once again, we're going to use a tree structure. First thing is we're going to start off with our game room. I'm just going to call that GR. And notice that there are 3 possibilities. Orange, yellow, and white. Orange, yellow, and white. Okay? Now for our entertainment center, there are also 3 possibilities. They can either, and those are ebony, cherry, or unfinished. So notice that we are constructing a tree again. Ebony, cherry, unfinished, ebony, cherry, unfinished. And once again, to write out the sample space, we just go down the tree. So, or we just trace each branch of the tree. So here we have orange and ebony, orange and cherry, orange and unfinished. Over here we have yellow and ebony, yellow and cherry, yellow and unfinished. And then finally, white and ebony, white and cherry, white and unfinished. And that's what goes into here. So, let me get over there first. OE, comma, OC, comma, OU, comma, YE, YC, comma, YU, and then finally WE, WC, WU. And there you go. Okay, 2 more questions left. What is the probability of rolling a sum of 12 on a standard pair of 6-sided dice? Express your answer as a fraction or a decimal rounded to 3 decimal points. To do this, we need a visual aid, and here it is. This is basically the set of all possible combinations when you roll 2 dice. Now remember, the probability of rolling a 12 is going to be equal to the number of outcomes which will produce a 12 divided by the total number of outcomes. And as you can see from here, these are the total possible equally likely outcomes. There happens to be 6 times 6 or 36 of them. So T is equal to 36. How many outcomes will produce for you a 12? This one right here. That's the only one. So there's only one. So that is your probability. That will be 1/tab36. And this brings us to our last question, which is also one that you have seen before. Which you have seen before. It's actually the last example in the 3rd lecture video. There are 102 identical plastic chips numbered 1 through 102 in a box. What is the probability of reaching into the box and randomly drawing a chip that is greater than 43? So the probability of getting a chip greater than 43, probability 43 plus. Okay, that's greater than 43. That's going to be the number of outcomes that are greater than 43 divided by the total number of outcomes. Okay, the total number of outcomes is is 102. The number of outcomes greater than 43 is going to be equal to 102 minus 43, which is 59. And therefore, this is going to be 59 divided by 102. So we can enter in 59 102nd, or we could write this as a decimal, which would be 0.5785784. So let's go ahead and see if that works. And it does. And that is how you do your homework. Now, relative to certifying, let's go to certify. Notice you're going to have the exact same questions, not necessarily in the same order, and you can get at most 3 wrong. If you get more, if you get more than 3 wrong, you need to recertify again. So out of 9 questions, or out of 9 parts of this homework, you have to get at least 6 questions right. And if you do that before the due date, you ace your homework. Okay, so that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.